Okay, on last week, Thursday, you guys learned what the derivative of sine of x was. Do you remember what the derivative of sine of x is? Yep. Now, if you'd like to, we could go through all of the rest of the, proofs, or you could just take my word for it. Which would you rather do? Okay. Yep, we're going to skip that. We're going to go derivative of cosine of x is negative sine of x. The derivative of tangent of x is secant squared of x. The derivative of cosecant, well, I usually do the derivative of secant first because I remember that all the time, is secant of x times tangent of x. The derivative of cosecant is kind of like the derivative of secant. It's just negative, and instead of secant, it's cosecant. And instead of tangent, it's cotangent. And the derivative of cotangent of x is negative cosecant squared of x. Yes, you need to memorize these. No, I will not give you these derivatives. So, as you said, I should be expecting more from you, not less from you. So, you were just referring to the final exam. Okay, all right. All right, so let's take the derivative of the following. Well, first let's look for some type of relationships that exist. Anybody notice something that stands out as you look at these derivatives? They all have an x. Awesome. Yeah, good. All the cos have a negative derivative. Cosine is negative. Cosecant's negative. Cotangent's negative. All the cos are negative. And whenever I memorize these, I never memorize all 6 of them. I just memorize sine is cosine. That's easy. I memorize tangent is secant squared. And then I memorize secant is a secant tangent. Then once I know those, I can figure out the others. Like, look, if the derivative of sine is cosine, then the derivative of cosine is going to be negative, and then just, opposite from sine, so, or opposite from cosine, so sine. Secant squared. If you go to cotangent, it's going to be negative. Instead of secant squared, it's cosecant squared. And if you look at these two, okay, you got secant tan. Well, this one's going to be negative, so it's going to be negative cosecant cotangent. So once you know these 3, you can memorize the others. And you guys are memorizing like 150 problems. If you do need to figure this out. So if you're so Grant, I saw you kind of shaking your head there. You can definitely see this. Like I've had many calculus classes where everybody tends to see, okay, these are positive, these are negative, and if you think of just sine and cosine go together, secant and cosecant go together. Tangent, cotangent, you could kind of make it out. But I believe in you. You can do it. You're smart people. Okay? And I know that you have to memorize 150 things anyways for Friday's Haney test, so you have no problem memorizing 6 derivatives. Wednesday, I mean, you guys are gonna have no problem. What? No, no. Okay. Gigi, a good question. How are you supposed to, in what way will we have to recite those for the test? We have to recite them right here. So f prime of x, I'm just going to expect that you're going to know these derivatives. So the derivative of negative 4x is negative 4. The derivative of tangent is secant squared of x. That's it. You see theta and it's scary. Oh my gosh. All right. It's a variable, kind of like x. All right, so this one, f prime of x. Now I need to know the derivative of 3 sine. What do you think is the derivative of 3 sine? 3 cosine. And what do you think the derivative of 4 cosine of x is? Negative 4 sine of x. And that's it. Everybody okay? Uh-oh, now we get a little bit more challenging. What's the derivative of 3x? 3. And now I've got x times cotangent of x. What rule have we learned that you think I need to use in order to find the derivative of x cotangent of x? The product rule. So I'm going to call this f, and I'm going to call this g. So you remember that the product rule is f prime g plus g prime f. So what's f prime? 1 times cotangent of x plus negative cosecant squared of x times x. I'm going to write that in a more user-friendly fashion. Hey, what happened there? F prime of x is equal to 3 plus cotangent of x minus x cosecant squared of x. That's it. What rule do you think I have to use for letter D? Many students use the quotient rule for letter D. I'm going to tell you that you don't need to use the quotient rule. Just ask Chris what to do instead. Chris, what should I do instead? Yeah, so Chris had an extraordinary college trigonometry teacher last year, and he told Chris that 1 over cosine is the same as secant. And you all remember that, right? Okay. That's something you're going to have to go back and you definitely need, there's some trigonometric identities that are really important for you. For example, cotangent of x is 1 over tangent. That needs to come back to your brain at some point. Cosecant of x is 1 over sine of x. That needs to come to back to your brain too. Secant of x is equal to 1 over cosine of x. Those are all very fundamental. Tangent of x is sine of x divided by cosine of x as well. Oh, wow. Oh, wow. That was below the belt. And I know that you all know what the capital of Washington, or the capital of the United States of America is. It's Philadelphia. So you also know that sine squared of x plus cosine squared of x is 1. And along with that, you also remember that 1 plus tangent squared of x is equal to secant squared of x. And you also remember that 1 plus cotangent squared of x is equal to cosecant squared of x. And of course, you would not forget your very important double angle identity, which is the sine of 2a is equal to 2 sine of x cosine of x. I would say that the things that I wrote on the board, those are ones that the AP exam would assume that you all remember. They're going to expect that you can pull those no matter what. Um, and I would say, Jake, Aaliyah, as you guys are, redoing some calc right now for your Northwestern professor, wouldn't you say that they've definitely exhausted your learnings in the trig area here pretty quickly? Times 3 or 4. So, yeah. So anyway, we can do it, folks, because you're super smart. So let's look at this. We are going to take 2 cosine of x, or 2 over cosine of x plus 3, and instead of taking the derivative using the quotient rule, we are going to rewrite it. It's just a lot easier. If you want to use a quotient rule, go right ahead. But it's a lot easier to just rewrite it. So f prime of x, what's the derivative of secant? Secant times tangent of x. So 2 secant of x times tangent of x. And then the derivative of 3 is 0. So we're done. There's no easy way to write letter E. There's no easy way to write that. So we are just going to have to use the quotient rule. Okay? So f prime of x says I have the derivative of the top. What's the derivative of the top? Cosine of x times the bottom minus the derivative of the bottom, which is times the top, which is all over excellent. Now, some people ask, Mr. Gens, when are we done? When is it simplified? And the answer is when you've combined like terms, or you've canceled out something that factors, or you've been able to substitute a trigonometric identity that is very fundamental, which would be all the ones I wrote on the board. We'd say those are very fundamental to what you need to know. So I'm going to take the chance of multiplying this stuff out and seeing if something will cancel. Let's see. We got f prime of x is, looks like I got x cosine of x plus cosine squared. And then I got 1 minus sine squared. Right? If these are conjugates, everybody? Yes? No? So if I multiply them, I'm going to get a 1 minus sine squared. So I'm going to have a minus 1 and a plus sine squared. What do you notice? Yeah, cosine squared plus sine squared is 1 because the capital of the United States is Washington, D.C. And so if this is 1 and a negative 1, that makes 0. So you're just left with f prime of x is x cosine of x over x plus cosine of x quantity squared. What is cosine squared plus sine squared? That is 1. Okay. So is that fair game? Something like that for the test? Yes, without a doubt. You need to know that sine squared plus cosine squared is 1. This is very important. Okay, very important. You can cross out the cosine of x's. You can cross out the x's. 1 over 1 squared is 1. Boom! What's up? So if I asked for you to write an equation for a tangent line, then you wouldn't have to simplify. But without a doubt, the AP exam is not going to leave the problem like that. I'll work on that. It's a goal of mine someday to be a grader for the AP exam. So yeah, I can't stand grading things, but I'm very, very interested to see. Yeah. Okay, so good little story there for you. Let's head off to this. What do you think about F? You tell me. Product rule. Very good. Chris sees the product rule. Let's do the product rule. We'll call this F. We'll call this G. Oh, yeah. So this should be F of theta. Good job, Zeno. F prime of theta. So what's the derivative of secant of theta? Secant of theta times tangent of theta. Times G left alone, which is theta plus tangent of theta. Everybody with me? Plus, what's the derivative of theta? 1. What's the derivative of tangent? Secant squared times secant. I'm going to multiply these in case something will combine together, or maybe something will factor out. So I get f prime of theta is equal to, so I could get theta, secant of theta, tangent of theta, plus secant of theta, tangent squared of theta, plus secant of theta, plus secant cubed of theta. Kind of tough to look at, isn't it? Okay, you'll want to go over the problem again later. Then make sure you get it. So what could I factor out? I could factor out a secant. Now, the question is it really necessary? Well, if it allows something to eventually kind of reduce, then it's a good idea. And in this situation, it will, hopefully, but we won't really know till we try. So let's see what we can do. F prime of theta equals secant of theta times, looks like I have a theta times tangent of theta plus what? Tangent squared of theta plus 1 plus secant squared. I factored out a secant. So I took a secant from here, 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 and here. And I put it out front here. Does anybody see something? Very good. Tangent squared plus 1 right here is secant squared of theta. So you end up with secant squared plus secant squared is 2 secant squared. So our final answer, f prime of theta, is equal to secant of theta times theta tangent of theta plus 2 secant squared of theta. And that's the derivative. Why? You don't. You don't. You could be like the guy with the pocket full of change. So All right, let's go to Dylan's favorite problem, okay? And Dylan's favorite problem he just talked about was writing an equation for a line. And the reason why he likes that is because he doesn't have to simplify it, okay? So let's look at this situation. It says, write an equation for a line tangent to f of x is equal to 1 minus the sine of x at x equals pi over 6. What two things do I need to write an equation for a line? What is my x value for the point on the line? Great. How do I find the y value? Plug it in. What's the sine of pi over 6? 1/2. Very good. And 1 minus a half is 1/2. So let's just review how you know that that's 1/2 real quick here. Last year, we talked about the circle of life, right? The unit circle. And you said pi over 6 was 30 degrees. This was 1. So you make a 30, 60, 90 triangle. So that's half. So this is the root of 3 over 2. So therefore, the terminal point was the root of 3 over 2, 1/2. Okay. And folks, it's okay to say you don't remember that. But there does come a time where it ends up being that's the measure of where you are as a math student. So it's not everybody here will get a 5 on the AP exam. Okay. So is sine the x value or the y value? It's the y value, so it's 1/2. Okay. So we have 1/2 right here. Now we need to find the slope. In order to find the slope, I take the derivative. The derivative is negative cosine of x. What is the cosine of pi over 6? There's a snake, it would bite you. It's sitting right there on the board, isn't it? The derivative of 1 is 0. So we've got negative root of 3 over 2. Okay. So now I'm going to write my equation for my line. Is this expected of you on the AP exam or on one of my tests? Yes, without a doubt. The difference is on my test, you also have the ability to use your calculator, though you will not be given that opportunity all the time on the AP exam. Okay, so we have y minus 1/2 is equal to negative root of 3 over 2 times x minus pi over 6. So if we simply just distribute, we have y minus 1/2 is equal to negative root of 3 over 2x plus pi roots of 3 over 12. And then I could simply add the 1/2 or the 6/12 over to the other side. And I get y is equal to negative root of 3 over 2x plus pi roots of 3 minus 6 over 12. Whoop, plus 6. So that's my y-intercept. That's nice and pretty. Where you can't use your calculator? We'll have one of those. Yep, don't worry. You'll have a test where you can't use your calculator. So. All right. Last problem of the day, and that is to set up a proof. Okay. So it's interesting to just see people's reaction because my daughter at home right now said, Kira, what's your favorite part of geometry? The proofs. I love them. I'm like, thank you. You know? All right. So we are going to go to your least favorite five-letter word in the world, proof or prove. But I'm going to show you that it's really quite straightforward. You are going to have to demonstrate this without a doubt. It simply says prove that the derivative of cosecant is -1 or negative cosecant times cotangent. I wrote it for you on the board. Now let's prove that it's true. No big deal. Instead of doing the derivative of cosecant, I'm going to do the derivative of 1 over sine of x. What rule could I use to find the derivative of 1 over sine of x? I could use the quotient rule. If I'm going to use the quotient rule, that means I take the derivative of the top. What's the derivative of the top? 0 times sine of x minus what? The derivative of the bottom, which is cosine of x, times 1 all over sine of x quantity squared. See anything that cancels or simplifies? 0 times sine is 0. So this becomes negative cosine of x over sine squared of x. Exactly. So you can see that it's really nice, and the best part about a proof is that the answer is already staring you right in the face, right? I mean, many math people really love proofs because we already know the answer. It's right there. What's that? These two mean the same thing. Okay. So I'm going to do exactly what Katie said, and I'm going to pull this apart. I'm going to pull this apart and write it as negative 1 over sine of x times cosine of x over sine of x. And Katie, she saw that. Others may say, well, why would you do that? Or how would you know to do that? Well, I need to come up with cotangent. What is cotangent? It's cosine over sine. I need to come up with negative cosecant. What's negative cosecant? Negative 1 over sine. I mean, it's right there. It tells you what it wants to be. So what's negative 1 over sine? Negative cosecant. And what's cosine over sine? Cotangent of x. Is that what we wanted to prove? It is. QED, which is Latin for that which was to be shown, now has been demonstrated. Oh, wow. You guys must have had a rough weekend. Like you were just like, I hate math. I hate it all. It's bad. It's like, you know, wait till you guys see what we do when you get back from your little finals thing here. I mean, then it's really, well, you guys think this stuff is hard. You haven't seen, wait till you see the chain rule and antiderivatives and stuff like that. You're going to be, yeah.